reduction factors, and that will be presented. I'll start over.
Sorry, Dennis.
Good morning. My name is Dennis Falloon, and I'm the District 7 Safety Academy Coordinator and a District 7 Safety Office Consultant. And I'd like to welcome you to the fourth webinar, Application and Science of Crash Reduction Factors, that will be presented by Larry Hagan, Professional Engineer and District 7 Safety Office Consultant. There are 12 webinars in the first series of presentations that run all the way through January 29th of 2014, and there will be another series of 12 webinars that will begin in February of 2014. However, they will be held every other week, and consideration will be taken for any holidays. Now I'll give you a brief introduction to the Academy. You can flip that.
Yes.
Don't mind. Basically, the Academy is here being presented through District 7 to provide information regarding the safety-related issues to enhance your local safety programs. Next. As I mentioned, this series of webinars did begin on Wednesday, October 23rd, and run through January 29th, 2014. They run between an hour and 2 hours. It gives, we have that allotted time. Length of each webinar will depend on the particular topic that's presented. As you can see here, and also in your invitation, you can go to see these two different web links to register for the Academy webinars, and you can get other additional information. And also on the invitation is the link to the previous webinars, both the PDF and the recording. Okay? As you can see, today is Application of Science and Crash Reduction Factors. So that's November 13th. So that's today's presentation. Go ahead and flip it. And there's my contact information, which you've seen previously. So, okay. I'm going to turn it over to Larry Hagan, and there you go, Larry.
Thank you, Dennis.
Okay.
As mentioned, today we're going to talk about the application and science of crash reduction factors, or my subtitle is Fun, Fun, Fun Till Your Daddy Takes the T-Bird Away. I hope to have a little bit of fun with this, and as much fun as you can possibly have with crash reduction factors. All right, as Dennis mentioned, you are here. The application and science of crash reduction factors is today's webinar, part of the series that you see in front of you. And so, like I said, you are here. Application and science of crash reduction factors. Let's start off with, what is a CRF? Well, CRF is one of the many TLAs that we use in traffic engineering. Here are some of the others. But you're probably asking yourself this question here, well, what's a TLA? Well, a TLA is a three-letter acronym. And like I said, here are some of the other TLAs that we use commonly in traffic engineering. Hopefully you know what these are. ADT is, of course, average daily traffic. Hello. HCM. Hopefully you know what the HCM is. It's the Highway Capacity Manual. HSM, that's one of the things we'll be talking a lot about today, the Highway Safety Manual. MOE. MOE is Mo, and of course, we all know what Mo is. Mo is that guy. So I'm Larry, Curly's there in the middle, and that over on the left side, that's Mo. Now, a little more seriously, MOE is Measure of Effectiveness. Measure of Effectiveness. And as it turns out, our topic for today, CRF, Crash Reduction Factor. Crash Reduction Factor is actually a measure of effectiveness. It's a measure of how effective you are at reducing crashes. So we'll talk about the crash reduction factor, and very much related to the crash reduction factor, or the CRF, is the CMF, the crash modification factor. Now, initially, when they were putting together the Highway Safety Manual, back in some of the research leading up to it, this was called an accident modification factor, and it was much easier to distinguish the two because you had the AMF or the CRF. But since, in safety practice now, we don't use the word accident. They're not accidents, they're crashes. We have the crash reduction factor and the crash modification factor. And so it's really important that you understand they are not the same thing. There's a relationship between them, but they are not the same thing, and it's important that you understand the distinction and the difference between them. And so let's look at that. Looking at crash modification factors versus crash reduction factor. Crash reduction factor, CRF, it's an estimate of the percentage reduction in crashes due to a particular countermeasure, and a CMF is a multiplicative factor used to compute the expected number of crashes after implementing a given countermeasure. So, slightly different definitions. They sound very close. They actually are very close, but they are different. And you can see that on this next slide. Comparing the two things, the crash reduction factors versus the crash modification factor. A crash reduction factor can range anywhere from negative infinity up to 1. Crash modification factor can range from 0 up to infinity. And so it's important to understand what the range of values for those two different things might be. If you have no change in crashes, if you have a site and you make a change, but there's no change in the number of crashes, you have a 0 crash reduction factor. Your crash modification factor is 1.0 because you made no change, and so you're multiplying what you had before with what you have. You're multiplying the crash modification to get what you have now, and if there's no change, you're multiplying by 1. And so for no change, CRF is 0, CMF is 1. Now, if you have implemented a countermeasure and you've eliminated all the crashes or all the crashes of a certain type, you may have a CRF, a crash reduction factor of 1 or 100%. You've reduced all the crashes. So crash reduction factor would be 1. Crash modification factor in that case, where you've eliminated all the crashes, is 0. If you double the number of crashes, so you've implemented a bad countermeasure and you double the number of crashes, your crash reduction factor becomes -1. You've added 100% more crashes, so it's a reduction of -100%. Whereas crash modification factor would be 2 when you double the number of crashes. Similar, when you cut the number of crashes in half, crash reduction factor is 0.5 or 50%. Crash modification factor, likewise, would be 50%. So going down just quickly through it, if you have 15% less crashes, your crash reduction factor is 0.15. If you have 15% less crashes after implementing a countermeasure, your crash modification factor is 0.85. And likewise, if you have 15% more crashes after doing something, crash reduction factor is -0.15. Whenever you see a negative crash reduction factor, that means you've increased crashes. And crash modification factor, where you have 15% more crashes, 1.15. Again, any number greater than 1 in the crash modification factor means you have an increase in crashes. Any negative number for the crash reduction factor means you have increased crashes. So anytime you see a negative number for crash reduction factor, that means you've increased crashes. Anytime you see a crash modification factor greater than 1, you've increased crashes. So just important distinctions there between those two different terms. And the formula between them, crash reduction factor equals 1 minus crash modification factor. Or if you prefer, you can flip those things around, and crash modification factor is 1 minus crash reduction factor. And so anyhow, that's the relationship mathematically between those numbers. All right, so when you're looking for crash reduction factors, where do I find them? Where do I find these things? There's 3 good sources. Florida DOT has a list of crash reduction factors. There's crash reduction factors in the Highway Safety Manual, and you can also get them from the CMF Clearinghouse. And we'll look at these 3 sources real quickly. Florida DOT has a list of crash reduction factors. These are from studies done in Florida. So these are, fairly local studies. If you go to DOT's website and you type CRF in the search box and let it search for CRF, it'll quickly find this report, and you can download the report, have it on your computer or whatever, print a copy if you like, or, whatever. So it's available from the Florida DOT website. And again, these are studies done in Florida. In 2005, it was updated by the Lehman Center at Florida International University based on some stuff they were doing with what's called their crash system, the Crash Reduction Analysis System Hub, where they put a bunch of data in from a whole bunch of projects and tabulated the crash reductions, and so they computed the crash reduction factors for all these different safety projects done throughout Florida. Just coincidentally, since we're here in District 7, everybody in District 7 hopefully knows Peter Hsu, and this was an update to the work that Peter did when he was a grad student at the University of Florida. Peter and Ron Atherley and Dr. Joe Waddleworth put out the first Florida Crash Reduction Factors report back when Peter was a young graduate student, and this just updated the work that Peter had done earlier when he was a grad student. Next, the Highway Safety Manual. The tables in the Highway Safety Manual contain crash modification factors, and I gave you the equation. You can convert crash modification factors to crash reduction factors if that's what you're going to need. An important thing is there are separate crash modification factors for the predictive models or the predictive methods of the Highway Safety Manual than for when you have specific project changes that you want to make, modifications that you want to make on a particular project. There's different CMFs for the predictive model versus regular project analysis. Typically, you don't want to cross those things. So the CMFs that are for the predictive methods or predictive models shouldn't be used for other project-specific stuff, and the stuff that's project-specific, those crash modification factors, you really shouldn't use when you're doing the predictive models. If you're going to do it at all, you need to do it with very, very extreme caution. And finally, the other source is the CMF Clearinghouse. It's cmfclearinghouse.org, or if you type in cmfclearinghouse.com, that will also work. But anyhow, Crash Modification Factor Clearinghouse, it's a website set up by the Federal Highway Administration, and you can look up all kinds of stuff on crash modifications there. It's a really great resource, and that's probably the go-to resource. It's probably a real good place to start. The Florida factors is also a pretty good place to start. Looking up the stuff in the Highway Safety Manual is fairly good as well, although all the stuff out of the Highway Safety Manual is already incorporated in the CMF Clearinghouse. All right, so again, cmfclearinghouse.org, great website. You probably want to bookmark that so you can find it if you're doing this type of work. I'm now showing my age. This is the robot from Lost in Space, and if you ever saw that TV show, you remember he flails his arms up and down, "Danger, Will Robinson, danger, Will Robinson." And I want to issue this warning. Always use caution whenever you're looking up or applying CMFs or CRFs, because it's easy to grab the wrong number. It's easy to grab stuff that's really not applicable. So throughout this presentation, you're going to see the robot here. Warning, warning, caution, be careful when using these things because it's real easy to misuse them. I want to talk for a second about the Highway Safety Manual predictive models before we get too deep into the CRFs or CMFs. I just want to talk about how crash modification factors are used within, this would be Part C of the Highway Safety Manual, because it's also important, and again, to distinguish how they're used in Part C, the predictive methods, versus Part D of the Highway Safety Manual, which is the project-specific stuff. So, for the predictive methods in the Highway Safety Manual, Joe talked a little bit about this. Joe Santos, if you were in last week's session talking about the Highway Safety Manual, and all the little check boxes here tell you where there are safety performance functions in the Highway Safety Manual for different facility types. most recently, they have approved safety performance functions for freeways and interchanges that aren't listed here, but they'll be in a future edition of the Highway Safety Manual, but that stuff is available now. If you search out TRB's website, you can find that information. The predictive models in the Highway Safety Manual, like I said, Joe talked a little bit about this last week in the webinar on the Highway Safety Manual. A safety performance function for each facility type. So for rural two-lane highways or rural multi-lane highways or urban and suburban arterials, there's a safety performance function for each of those. Crash modification factors that are applicable to those particular facility types. We apply a local calibration factor, and Joe talked a little bit about that. And then if you have existing crash data, you can do an empirical Bayes adjustment, the EB adjustment. When you start talking about the empirical Bayes, this is the point where most people tend to kind of glaze over in their eyes and fall asleep or something like that, because very few people really have a grasp for what the EB is all about. In the next series of webinars, I hope to do a webinar basically EB for dummies. Not that I'm calling anyone a dummy, just to try to make it understandable and simple what the EB is all about. So at some point in the future, we'll talk more about the EB, but we're not going to really do much EB adjustment talk here today. So what are the safety performance functions? Safety performance functions, it's a regression model for roadway segments or intersections based on the facility type. It's developed from data for a number of similar sites, developed for specific site types and base conditions. And I'll explain that as we get a little further into what the base conditions are all about. It's fairly important you understand the base conditions. Typically, the predictive models are a function of only a few variables, primarily AADT. So you go into the function with AADT and you come out with a prediction of crash frequency. And it's used to calculate the expected crash frequency for the base conditions. Then we apply the crash modification factors to the predictive model to adjust it from the base conditions to your real conditions. So again, it just accounts for the difference between the base conditions and your site-specific real conditions that you're trying to analyze. As an example, this is the safety performance function prediction model for base conditions for a rural two-lane roadway segment. And so you go in with the length of the segment and the AADT, and you can compute a predicted number of crashes per year for that segment, under base conditions. So the question is, what are base conditions? Base conditions are these things listed here. 12-foot lane widths, you have a 6-foot paved shoulder, roadside hazard rating of 3. Roadside hazard rating we're not going to get too deep into, but it's basically a qualitative assessment how dangerous the roadside is or how good the roadside is. Do we have decent clear zones? Are there steep slopes and those kind of things? And so I just refer you to the Highway Safety Manual to look into that. As I started looking through the Highway Safety Manual and first getting into when it was first produced, it reminded me of, in the early editions of the Highway Capacity Manual, if you did signalized intersection analysis, the arrival type. The arrival type, the default arrival type was arrival type 3. And just like this, the default roadside hazard rating is roadside hazard rating 3. And then if you had really good signal progression in the highway capacity analysis, you would have a different arrival type. Or if you had really poor signal progression where all the traffic arrives right at the beginning of red, you had a real bad arrival type. And so the roadside hazard rating is that same kind of thing. It's a qualitative assessment of how safe or unsafe the roadside environment is. And so again, the roadside hazard rating of 3, which is kind of in the middle, there's better roadsides and there's worse roadsides that you can have. And again, I'll just refer you to the Highway Safety Manual to check that out some more. Some of the other factors related to the base conditions, 5 or less driveways per mile, 3% grade or flatter, no horizontal curves, no vertical curves, and so forth. And so these are, the base conditions. And so it's assumed that, this is the perfect road, has these, or this is the ideal road, has these characteristics. And then if you have something different than this, there's a crash modification factor. So if you have a lane width that's less, you'll have a crash modification factor that you would apply. If you have a lane width that's more, a different crash modification factor that you would apply, and so forth. All right, so we apply all these crash modifications for each of those factors that are different, and then we apply the calibration factor, which is a local calibration factor. And Joe mentioned that last week some. The calibration factor, Florida DOT is soon to complete a project. They have some preliminary values out there, but soon we'll complete a project where they'll have calibration factors for Florida to convert what we get out of the standard highway safety manual analysis to a good Florida number. Here's an example of one of those crash modification factors looking at lane width. And actually, this is not really a crash modification factor. One of the things they're evolving towards is not crash modification factors, but crash modification functions, because it's not really just a factor you're pulling out, it's a function. You can see here it's a function of the AADT. And so we'd go into this table, and based on the AADT and the lane width, we would compute a crash modification factor. Important thing to look at the notes below these tables when you get into this type of analysis, when you're looking at crash modification factors or turning those into crash reduction factors. The note at the bottom of the table says the collision types related to lane width to which this CMF applies include single vehicle run off the road, multiple vehicle head-on, opposite direction sideswipe, and the same direction sideswipe crashes. And so those are the collision types related to this crash modification factor. So this crash modification factor that you pull out of, or the number that you pull out of this crash modification function, is just related to those crash types. And then you use the equation shown beneath that table and to compute, what is the real the total overall crash modification factor related to lane width, for adjusting for this particular site. And you have to know what's the proportion of related crashes. So what proportion of all of my crashes are those collision types? The default value is shown there, 0.574, meaning that 57.4% of the crashes are of those types listed in that note, and the remainder are other types, that aren't going to be impacted by lane width. That's the default value. If you have better local data, use your better local data. And so we want to make sure we use better local data when we can. District 7 generally has good data out of their crash data management system, and so you can use CDMS to get local factors if you have a real need to get that deep into creating these crash modification factors. Again, warning, always use caution when you're looking up or applying crash modification factors or crash reduction factors. The table I just showed you is only applicable when you're using that predictive model for rural 2-lane roadway segments. It's not applicable for anything else. So, that was for a very specific use. So again, it's not going to be applicable for anything else. All right, a couple other things. This text comes straight out of the Highway Safety Manual. In the Part C, that's the predictive method. Basically, if you have your Highway Safety Manual, it's Volume 2. Volume 2 is the predictive method. The CMFs are multiplicative because the effects of the features they represent are presumed to be independent, it says here. And so for the predictive methods, you can apply all of those multiplicative crash modification factors for all those things that I listed there, lane width, shoulder type, presence of speed enforcement, lighting, all those kind of things. If you have something different than the base conditions, you want to and should apply all of those crash modification factors. The presumption is they're independent. And then it goes on to say, however, little research exists regarding how independent these things really are. And so, future HSM editions may be able to address that independence of these effects more fully. So anyhow, that's an important warning to understand. Again, that's straight out of the Highway Safety Manual. Now, Part D of the Highway Safety Manual, which is the project-specific stuff, not the predictive. This is Volume 3, the third big volume of your Highway Safety Manual set. It tells you there's limited understanding of the interrelationships between the various treatments presented in Part D, and it requires consideration, especially when more than 3 CMFs are proposed. If the CMFs are multiplied together, it's possible to overestimate the combined effect of multiple treatments when it is expected that more than one of the treatments may affect the same type of crash. Basically, again, it's talking about the independence. When you're using multiple CMFs, you need to have the understanding they're expected to be independent. So when CMFs are multiplied, the practitioner accepts the assumption the effects represented by the CMFs are independent of one another. So again, it gives you good caution here on when to use multiple CMFs. And basically what it's saying is you don't want to apply too many CMFs when you're doing Part D type site-specific safety analysis work. So I hope that's somewhat clear. The predictive model expects you to use all the applicable crash modification factors for all those base conditions that are listed. When you get into analyzing specific roadways, specific sites, the Part D stuff, you don't want to use too many crash modification factors. It says, typically you don't want to use more than 3, and so be very cautious in using them when you're doing site-specific safety analysis. Again, the compatibility of multiple CMFs, just another warning straight from Highway Safety Manual. Certain CMFs used in the analysis of existing site conditions and the proposed treatment may not be compatible. So if you have some CMFs that you applied to your existing site, and then you're looking at a proposed treatment, well, maybe some of those CMFs are no longer compatible, no longer appropriate. And so, again, you need to be very cautious in applying the CMFs. You have to have a lot of forethought to really apply the right CMFs in the right location at the right place to the right types of crashes. And we'll look at that as we go through the slides here. And again, there's my warning, danger, Will Robinson, danger, Will Robinson. Always use caution when you're looking up or applying crash modification factors or crash reduction factors. Especially, you must use extreme care and extreme caution when you're trying to combine them. And never try to combine CRFs, okay? Never combine CRFs, okay? Nike says just do it when it comes to combining CRFs. Larry says just don't do it, okay? Just don't do it, because it's typically not going to work well. CRFs certainly are not additive. You certainly don't want to just add them up. So for instance, if you have one thing you're going to do has a 25% crash reduction factor, and you're going to do another treatment as well, and that gives you a 35% crash reduction factor, you can't just add them up and say, wow, look at that, 60% crash reduction. It doesn't work that way. It doesn't work that way at all. So again, they're certainly not additive. What you want to do is convert them to crash modification factors. If you're going to look at combining them, if you're going to do it at all, if you're going to combine them at all, convert them to crash modification factors and multiply them together if it's applicable, if they're independent, if you can really justify that they're independent, and if they're both applicable. So like I said, combining crash modification factors, they're multiplicable, multiply if they're applicable, if they're independent, and those kind of things. You want to definitely consider their independence, consider how independent they are. Is there no relation between them, or are they kind of related? And one of the earlier slides showed, if you're widening a lane and widening the shoulder, those two type of things are probably going to address a lot of the same crash types. Are they really independent? Probably not. And so you want to really look at, are these two things independent, and be real cautious when applying multiple CMFs. And like I said, you typically don't want to use more than 3. For the HSIP projects, typically what the direction has been from the department is use 1. Use the one that's either the highest or use the one that's most reliable. And we'll, as we get a little further into this, we'll talk about the reliability of crash reduction factors. But you want to use, typically just 1. If you really have a couple and you can really justify and document that they're independent, it would be possible, use the crash modification factors and multiply them together. But again, it's best to stick with just 1 and just find one that's good and reliable. If you're doing multiple improvements, find the one that you have the best comfort level with and stick with that. All right, I mentioned the crash modification clearinghouse. Let's go back and look at that a little bit. If you go to cmfclearinghouse.org, it takes you to the web page. Hopefully you see something somewhat like that. One of the things you see at the bottom of the screen there, here are some recently added crash modification factors. And just scrolling down a little bit, here are 3 of the recently added crash modification factors. They add stuff to the crash modification factor database. I believe it's every 6 months. It's either every quarter or every 6 months. I'm pretty sure it's every 6 months. Because there's a fairly rigorous process they go through to evaluate, how good is this information, before they send it out and put it out there on the website for everybody to consume. So, here's some recently added crash modification factors. I'm going to look, we'll look a little closer. The one in the middle says installation of a hawk. So we're going to look at installation of a hawk. And so when you click on that, it gives you this information. And right at the top of this, you see the star quality rating. And so let's look at what the star quality rating is all about for this crash modification factor, and where does the star quality rating come from? Well, like I said, it's a rigorous process they go through looking at all the studies that are submitted for these crash modification factors. The submitted studies are ranked in the categories shown on the screen there. They look at the study design, the sample size, what's the standard error, what potential bias might exist, and what's the data source. And for each of those criteria, they rank it either excellent, fair, or poor. And you can see all the criteria within each of those boxes there for what it takes to be excellent in study design, or fair, or poor, and so forth. So here's a criteria here for how they rank all the submitted studies that are submitted to Federal Highway, and if it is rated as excellent in a particular area, it gets 2 points in that area. If it's fair, it gets 1 point. If it's poor, it gets 0 points in that area. And so, again, it's a rigorous process. All these things are evaluated by a committee of people looking at it, and these studies are ranked in all these criteria and points given in all those different areas there. Then the star quality rating. The final quality rating is a weighted score. They take 2 times the point value for the study design, 2 times the sample size point value, standard error, potential bias, and data source values, and they add all that up, and that's the score. And so they have weighted a little bit heavier having a good study design and having a good sample size. So those factors are weighted twice as heavy as the standard error, the potential bias, or the data source. So it's leaning more towards having a good study design and having a decent sample size. And then once the score is computed, the star is based on the score. And the star rating is based on the score, so that's how you get the star rating. So again, looking at the crash modification factor clearinghouse, for the one we were just looking at, the safety effectiveness of hawk pedestrian crossing treatment, installation of a hawk, it has a star quality rating of 3. And so we get a crash modification factor 0.309, which translates, to a crash reduction factor of 69%, 0.69, which you see there at the bottom of the screen. Scrolling down a little bit, it tells you what this factor is applicable to. It says that this is applicable to vehicle versus pedestrian crashes only. And so it's not for all crashes, it's just for vehicle pedestrian crashes. And so a 69% reduction in vehicle versus pedestrian crashes by putting in the hawk here. Tells you what roadway types were in the study, and in this case not specified, which crash severities were addressed, and so forth, speed limit in the places where the studies were done, and so forth. So this is where you get more information about each of the crash modification factors or crash reduction factors that you can pull off the CMF clearinghouse, and then you can see how applicable is that to the study I'm doing, to what I'm doing. So that's how you get the information out of the crash modification factor clearinghouse and how you can start to use it. All right, let's go back and let's see if there's some other CMFs related to the hawk. So you just go back into CMF and just type in the word hawk, and when you do that, it says there's 3 CMFs returned for your search on hawk, and they all fall under the category of pedestrians. So you click on pedestrians down there, and it tells you here are the 3 CMFs related to putting in a hawk. And let's see what we got here. This first one here, hopefully you can see that on your screen. You get a CMF 0.712, which results in a crash reduction factor 0.29, 4-star quality. It's addressing all crash types, all crash severities in urban and suburban environments. And so, again, installation of a hawk should give you a 29% crash reduction factor, based on this study here. And again, the crash modification factor clearinghouse, you can click on the reference there and, click on where the crash modification factor is and dig deeper into where it's applicable, where it was studied. You can often get the full reports if you want to really dig deep into the studies that were done for each of these crash modification factors. The next one, it's 0.849 is the crash modification factor, or a 15% crash reduction, 15% CRF, 3 stars, but you can see there crash types are all, but this is looking at just the fatal and serious injury crashes. So, the number we had before, 29% reduction in all crashes, but we see a 15% reduction in fatal and serious injury crashes by putting in the hawk here. And then the next one is the study that we looked at earlier. Again, 69% reduction in vehicle versus pedestrian crashes. So 3 different factors, 3 different crash modification factors here for the same countermeasure, installation of a hawk. And so, how do you choose between similar ones? Well, in this case, it was real easy. The first factor was for all crash types, all severities. The second one, all crash types, fatal and serious injuries only. And the third one was just looking at vehicle versus pedestrian crashes. And so there are 3 different factors really for 3 different type of things. But one of the great things the CMF clearinghouse also answers is the question of, are you having trouble deciding between similar crash modification factors? If you look up at the top of the screen where that red arrow is, if you're having trouble deciding between similar CMFs, check out the FAQs. And so when you click on the FAQs, How do I choose between CMFs in my search results that have the same star rating but different CMF values? And sometimes you might have different CMFs and same star ratings, and which value do I choose? It gets to be a really big decision, and so you have to start looking real deep into the various studies and what is this applicable to, what type of area was this data collected in, and so forth. So you want to find the CMF that's most applicable to what you're doing, your site that you're looking at, or the area you're studying. And so you want to have CMF studies that closely match the characteristics of the site you're looking at. So looking at the table here, and this is the installation of a left turn lane on a single major road approach. The 3 CMFs all have 5-star ratings, so they're all really good, statistically valid values, but the CMF values are all over the place. And at first glance, you say, wow, which one do I use? Do I just choose the best one? Well, no, you want to dig in and figure out which one is really the most applicable one. Scrolling down a little bit, you can see if you look closely, the first one, like the others, they all address all crash types and fatal and serious injury and minor injury severities. Roadway types weren't specified. The first one is for rural roadways, so it's a rural area type. So if you're in an urban setting, okay, you can exclude that one. That doesn't, that's not the one you want to use. Then you start looking at the second one and the third one, and in one case the CMF is 0.71 and the other one is 0.91, so fairly big difference there. So you have to dig a little bit deeper, and when you start digging a little bit deeper, you find that the 0.71 value is for a stop-controlled intersection where you've added this left turn lane, and 0.91 is for a signalized intersection where you add a left turn lane. And so you have to dig a little bit deeper into the CMF clearinghouse to figure out which is which. And so again, this just highlights, again, you need to use caution when pulling numbers out of the CMF clearinghouse. Make sure it's applicable to what you're really trying to study. Yeah, so this one, the first one is the rural, and then this, just highlighting there again, one is for stop-controlled intersections and the other for signalized intersections. The FAQs, just showing the FAQ screen here, a lot of different frequently asked questions in the clearinghouse, and it gives you good information on how to make sure you're getting good data out of the clearinghouse. The clearinghouse is a great resource. You want to use it, but you want to use it intelligently and properly so that you get good data out of it. Otherwise, it's garbage in, garbage out for sure. All right, let's look at another example. I submitted protected left turn. And so there's 67 CMFs related to protected left turns. And 3 of them are in the category of intersection geometry, and 64 of them are in the category of intersection traffic control. And so under intersection traffic control, here are some of the 64. And you can look in there, there's a lot of information there, different things where you're changing from permitted or permitted protected to protected, change from permitted to protected on the minor approach, and so forth. So, a lot of different, sub things to choose from, sub countermeasures under intersection traffic control here. Looking at just 3 of them, and so change from permitted to protected on the minor approach. You can see in the top one up here, I've got a 99% crash reduction factor with a 5-star quality. But what that's saying is I can reduce 99% of the angle crashes, because look at the crash type there. Let me highlight that. So looking here, 99% crash reduction factor, crash modification factor 0.01. In 5-star quality, really good quality study, but this is just related to angle crashes. So I can reduce 99% of my angle crashes. Okay, and in terms of all crashes, my crash reduction factor is 18%, and not near the star quality there as well. Changing from protected permitted to protected on just the major approach, again, same kind of thing, 99% crash reduction factor, good quality, but again, I'm only looking at angle crashes in terms of that crash reduction. That's only going to reduce 99% of the angle crashes. And likewise, going from permitted protected to protected on the minor approach eliminates 97% of the angle crashes. Again, 4-star quality here, so still good quality numbers, and you can see in terms of reduction of all crashes, and not a big deal. So changing from permitted protected to protected, if I don't have an angle crash problem, it's not going to really affect the safety a whole lot. So, not much crash reduction there for that type of thing. All right. And a lot of this has to do with precision versus accuracy. When you see great differences in some of the crash modification factors, you can get estimates that are very precise, where they're all very similar, but they may still be pretty far off the mark. Or sometimes you see crash modification factors that are really just all over the place, that are neither precise nor accurate. And again, it's something you need to be aware of, that some of the studies might be all over the place, neither precise nor accurate. Some might be precise but not accurate. What you really desire is having good precision and good accuracy. All right, let's look at another example. I typed in a roundabout, and so again went to the crash modification factor clearinghouse, just typed in roundabout. And so 134 crash modification factors in 4 different categories related to roundabouts. And so to start searching for what good would a roundabout do us? And there was 113 of them just in intersection geometry, and you can see some of them listed there. Lots and lots of different countermeasures when you're doing things, converting an intersection into a low-speed roundabout, countermeasure for converting an intersection into a multi-lane roundabout, or so forth. And so you can hopefully drill down to find a good countermeasure or good crash modification factor for the particular type of change you're doing, particular type of countermeasure that you want to implement. All right. Now, looking down at some of these, we're going to convert a no control or yield intersection into a single or multi-lane roundabout. And we can see when we do that, convert intersection that's got no control or yield control into a single or multi-lane roundabout, crash modification factor 1.242, crash reduction factor is negative 24.18. And so again, what does that mean when this is above 1 and this is negative? That means we see an increase in crashes. So going from a no control intersection to a multi-lane roundabout, it increases the number of crashes, all crashes, crash severity, all, so we see an increase in number of crashes. But look at what we see here, the next crash modification factor. Crash modification factor of 0, crash reduction factor of 100, for fatal, serious injury, or minor injury crashes. So fatals or injuries go completely away, 100% reduction in your injury crashes or fatal crashes by going from a no control to a single or multi-lane roundabout, according to this study here, from the crash modification factor clearinghouse. So completely eliminated all fatals and injuries by going from no control to roundabout control. And so all the injuries, all fatalities completely go away, but we see a 24% increase in minor fender benders. And that's the kind of thing that, often happens at roundabouts, increase in fender benders, but since everybody is going the same direction, the severity, drops way off. And in this case, the studies show, severe crashes went to 0. Now looking in the next one a little bit, you can see the same kind of thing. Reduction in this study here, converting a signalized intersection into a roundabout. Crash reduction factor of 19% in terms of all crashes, in terms of serious injury or minor injury, 71% reduction. Look at this one down here. Very little change in this particular study. 4.5% crash reduction in terms of all crashes, all severities. Again, converting a signal into a single or multi-lane roundabout. Interesting stuff there. All right. Converting a stop control intersection to single lane roundabout. Again, same type of factors, same type of good quality studies, various crash reduction factors in there. Interesting when you start looking at this and looking all of the down at the bottom here, converting an all-way stop. Again, you see an increase in all crashes, but in the injury crashes and fatal crashes, you see a decent reduction, 45.6% crash reduction for the fatal, serious injury, and minor injury crashes, but nothing like the 100% reduction that we were looking at before. So I guess the real thing is we want to convert your all-way stop control intersection to a uncontrolled intersection first, and then convert it into the roundabout, and that'd eliminate 100% of this stuff, right? Well, I don't know. Don't know that it would work that way, but anyhow, that shows you, again, the accuracy and precision of some of these things, and that you have to be real careful in how you apply these crash modification factors.
Larry, quick question in the chat room. As a clarification, the star rating is a quality of the study, not a quality of the countermeasure.
That's correct. Yeah, the star quality really is the quality of the study, and it gives you a little bit a quality rating of the crash modification factor itself, in that it shows that the number that came out of the study looks like it is fairly reliable. It looks like it was a good sample size, looks like we had a good study methodology, and it's all those criteria that we had listed. It really is the quality of the study, but it also is kind of pointing to how good the number is, because the number is the result of the study. So that's an excellent question. But yeah, the star quality really is the quality of the study, but since the answer, the crash modification factor or crash reduction factor, is the outcome of the study, it kind of is also the quality of that number, how reliable we believe that number is. So excellent question. All right, and so, there we go. Yeah, talking about accuracy and precision, I combined on this slide two different figures out of the Highway Safety Manual just to show you the how really you do have to be careful in applying these things, and kind of take it with a grain of salt, in that some of the numbers are really shown to way too many decimal places, in that the numbers really aren't that reliable and that good. The dots that are shown here are from a bunch of studies, study of two-lane rural roads in Colorado, accidents per mile of two-lane rural road per year versus AADT. And the red line that's shown there is the safety performance function for base conditions for a two-lane rural road. And you can see how the data is scattered all over the place. And that's fairly typical of safety data. There's a lot of variables, a lot of things that aren't really corrected for. And so you want to use good crash reduction factors that are the best you can get your hands on and the most reliable you can get your hands on. But again, you need to be cautious in using them, because there's so many things that aren't accounted for. Like, for instance, you did not see in the listing of all those different crash modification factors, or the base conditions, if you will, for a two-lane rural road. You saw nothing in there on weather conditions, or days of sleet or days of ice. And certainly if you have a road where there's absolutely no ice or no snow or nothing like that, you're going to have different safety numbers than a road that's constantly got black ice on it and vehicles are sliding all over the place. And so some of those things just really aren't corrected for. And so again, what we get out of the crash modification factor clearinghouse is an average of a bunch of studies, and what you're going to have is going to be hopefully somewhere close to that, but there will be some variability built in, and just need to understand that and be prepared for that. Let's look at another example, and just going to look here. Let's say we've got a two-lane rural roadway with an AADT of 16,000. Let's say we're having nighttime crashes and wet weather crashes on it. Let's say it's a county-maintained roadway that doesn't have any RPMs on it currently. RPMs, we typically put them on state roads. Local roads, they're not required. I mean, the MUTC does not require RPMs. It's a supplement to the lane lines, and so it's a good thing to put out there. It's a useful thing to put out there, but they're not always out there on local roads. And so let's say there's no RPMs on this road, and we say, gosh, there's a lot of wet weather crashes, nighttime crashes. RPMs might be a good countermeasure. Let's see what would be the effect of putting in RPMs. And so if we open up our Highway Safety Manual, Part D, and we want to enhance the delineation, that's what we're doing by putting in RPMs. There is a table in there, the potential crash effects of installing snow plowable permanent RPMs. And so we're looking at installation of snow plowable permanent RPMs. And so, again, my warning, danger, Will Robinson, danger. Always use caution when you're looking up or applying crash modification factors or crash reduction factors. The text in the Highway Safety Manual clearly says installation of snow plowable permanent RPMs. If you've never seen a snow plowable RPM, they are a little different than the ones we typically use in Florida. Often the outside of it is made of stainless steel. They do make some now out of a really hard resin, but it's got an outside shell that helps lift the plow over the RPM so that the RPM is not scooped up by the snowplow. And so it's a different installation method. Typically, there's a little post that sticks in the bottom of this unit, and you have to drill a hole, epoxy it in, and it's much more expensive and much more difficult installation than what we typically do in Florida. But, that was the only real countermeasure in the HSM related to putting in RPMs. So the question I would ask, isn't every RPM that's installed in Florida resistant to every snowplow that's typically used in Florida? I mean, since we don't really go out and snowplow the roads, every single RPM is probably technically snowplowable since we don't really use any snowplows. So is this an applicable crash modification factor, or could this be an applicable crash modification factor? Well, proceed with caution, I would think. This might be something, at least a starting point, something to look at. So let's proceed with it. You want to check the notes of the underneath the table, and the notes in this case are generic. Tells you the bold text is used for the most reliable CMFs. So that means ones that would have real high number of stars in the star rating factor. And so these crash modification factors have a standard error of 0.1 or less. So, I mean, they're fairly reliable, good CMFs. And, any that are in the table with an asterisk, So there's some variability, could be an increase or decrease or no change in crashes, and so forth. And so going back to our table, all of the numbers that are shown in the table, all these numbers over here are in bold, so they're all, good and reliable numbers. A couple with stars here, 0.99 and a 1.03. So those are fairly close to 1, and so that just means, well, there could actually be a slight increase or a slight decrease, or it could be the same, and you'll see that all through the Highway Safety Manual. It's interesting, when I started looking at this, crash modification factor is greater than 1. And so you start thinking about, does that make sense? Crash modification factor greater than 1 for just installing RPMs. I mean, gosh, you would think, doesn't installing RPMs make the road safer? But in this case, it's saying there's an increase in crashes for installing snowplowable RPMs. And, how does that make sense? And so, again, next step, check the text. Read some of the text in the Highway Safety Manual, and, some of the things that you see in the text. The varying crash effect by traffic volume likely due to the lower design standards for low volume roads. When you provide improved delineation, it may cause drivers to increase their speeds. So the fact that you've made it better, you've improved the delineation, may make drivers feel a little safer driving faster. And so the varying effect by the curve radius is likely related to the negative impact of speed increases. So again, you've improved the delineation so people can see the roadway better, see the alignment better, and maybe they're going to drive faster and take more chances. And again, this countermeasure is based on snowplowable RPMs, so the presumption would be that's a place that has ice and snow. And so if you're driving faster on roads that have ice and snow, that could result in an increase in crashes. I guess that would make some sense. And so that's how you make sense of some of that. So looking at it again, the crash modification factor that we're going to pull out of this table applies only to nighttime crashes, all types of crashes, but only nighttime crashes and all severities. So, again, we're looking at our two-lane rural road. Our AADT was 16,000. Let's go back to our table. And with an AADT of 16,000, we can come up with a crash modification factor of 0.76. Okay, so a rural two-lane road, and I'm assuming I've got a tangent section here, so my radius is greater than 1,640 feet. And so based on the AADT, I can come out of my table with a 0.76 crash modification factor. Looks pretty good. So what does Larry the engineer do with that? Well, out of the table we pulled this crash modification factor. 0.76 results in a crash reduction factor, 0.24, 24%. Again, remember, this is nighttime crashes only. That's what the data is all about, nighttime crashes only. Maybe I'll be a little conservative, crank it down a little bit, and use 20% number, because there's certainly a lot of assumptions and if built into this. And so I might use a 20% factor, be a little conservative, crank it down a little bit, again, applying it only to nighttime crashes, so reducing 20% of my nighttime crashes. But a good thing to really do is, if you implement this, perform before and after study. See how it really does perform. And then submit your results to the CMF clearinghouse so we can have more data, better data for future studies. Because, again, it's a little bit of a stretch because you're using a crash modification factor, in this case, for snow plowable RPMs, so you're assuming it's someplace other than Florida where all these studies have been done. And so maybe we can come up with something a little bit better that would apply to Florida roadways and submit it to the clearinghouse so hopefully other users later down the road can use your factors. Okay, I told you at the beginning we're going to have fun till your daddy takes the T-Bird away. And it looks like Dad's taking the T-Bird away. So with that, I'm going to wrap it up and take any questions. So if you have questions on crash modification factors, crash reduction factors, type them into the chat box and we'll chat about it. Do we see any questions? I don't see anything there.
And no questions have been asked so far.
All right. Well, does anyone have questions, or everyone still, is everyone asleep? I hope I didn't put you to sleep. I hope we did have fun. Hope you learned a few things. Saw some things in crash modification factors that you weren't aware of before, but again, the main thing is there's a whole lot of information out there on the CMF clearinghouse, and just got to be careful in using it.
I'll go back to a slide because I actually have a question. Asking how often are FDOT production factors updated?
FDOT right now, I don't believe is updating. Well, I take that back some. I know District 6 is, or at least I believe District 6 is still working with Florida International University there, and Dr. Albert Gann, who created that crash program, and they're still getting some updates to some of the FDOT crash reduction factors. So I don't know that any updates have been published since 2005, but I believe the FDOT factors, 2005 factors were pretty good and can still be used. Again, it's like anything else. You can pull them from the crash modification factor clearinghouse or pull them from the DOT data. Either one can give you good data, but you just need to be real careful in picking the right numbers to use.
The discussion, I think, Larry, that would benefit some folks, and I don't know if this was brought up specifically. I went back to one of your slides to show for pedestrians the hawk.
Mm-hmm.
There is
right.
a crash reduction factor of 29% for all crashes, and there is a crash reduction factor of 15% just fatal serious injury crashes. If you were doing a study or a justification to install these and you were particularly interested in targeting your fatal and severe injury crashes, which crash modification factor would you use? I mean, all crashes are technically considered as, a fatal crash is an all crash.
Yeah.
So
right,
this seems contradictory in the CMF clearinghouse. Do you see what I'm saying?
Yeah, I see what you're saying, and I mean it's one of those things. If I'm targeting
fatal and serious injury, can I not use the 29% and just say that it targets my fatal serious injury plus a couple of property damage only crashes?
Yeah, I mean I would again be real cautious. I'd look at both numbers because look at both numbers, especially if you do have a history of fatal and serious crashes, and so some real numbers there that I had 10 crashes in the last few years that were fatal and serious injury. So being able to reduce 15% and being able to attach real numbers to that is helpful. If you haven't had any fatal or serious injury crashes, if there's only been one, and you say I'm going to be able to reduce 15% of my one fatal and serious injury crashes, that doesn't say a whole lot. And so I'd really tend to look at both numbers and see which one really gives me the best feeling about how well it's going to perform. If I have a real fatal and serious injury type crash problem, I'd lean towards using that number. If fatal and serious injuries aren't things that are really showing up at this time, at that location, I'd stick with the all numbers. So. But again, you'd probably want to dig further into each of the studies and where the CMF value is shown there, you click on that and it gives you more information about that particular study and how it was studied, where it was studied, and the applicability of it. And so I just dig in a little bit deeper.
Yeah, thank you. I mean, I wanted to just throw that out for the audience to hear that there is a bit of an art to doing this. It's not as clear cut as look up the countermeasure, plug in the number. This challenge also comes up if you're applying more than one countermeasure at a location. But some countermeasures will have a higher crash reduction factor, some will have a lower one. So it depends on what you're trying to target. The key, if you were doing, if you were calculating a benefit cost ratio, for example, just the benefit portion of it is what these numbers go towards. The key to it is to not double count the crash. So apply the best countermeasure to each crash that passes the sniff test, and don't double count them down the line. So if you apply that 29% to some, and then the 15 to the others, and then work down the list when you're doing your benefit calculations.
Right, exactly. I mean that goes to the whole point about using multiple crash modification factors. Presumes that there's independence among them, and if they're really not independent, then you have to be really, really cautious in using more than one, and especially 2 or 3 or 4. You want to make sure they're really, really independent type things if you're using more than one crash modification factor.
Where should people go first, Larry, for crash modification factors? Is it the CMF clearinghouse? Is it FDOT's crash reduction factors? I know FHWA has a section on, sort of effective countermeasures that work. Who's the primary source?
I'd start with the CMF clearinghouse mainly because, FHWA is working hard to keep it up to date, and so research from all over the country is combined in there, and so it's a pretty good place to start, and especially because, like I said, you put in roundabouts, and I forgot how many, 137 or some odd different countermeasure types, just related to roundabouts, and so you can probably narrow it down to something really specific to each particular countermeasure you want to implement. And so it's a good resource to start with the CMF website. So I think that's really a great place to go. You'd have the latest research, and the star quality indication does help show you whether it's something that seems fairly reliable or something that's kind of suspect, and so that's good information. The DOT numbers also not a bad place to go. I'd probably start with the clearinghouse first, just because it is more recently updated. The DOT numbers are Florida studies, so particularly if you get to something and it just looks way out of whack, look up the Florida numbers and see if there's something in there, and if it's close. And if just your gut tells you the number up from the CMF website is way out, in left field, maybe there's a Florida number that you can have a little more comfort with. And so the Highway Safety Manual, like I said, everything that's in the Highway Safety Manual is on the website. It's built into the CMF clearinghouse, so it's a little redundant to use the manual, but I'm enough of an old-timer that I still do sometimes like to flip pages, and so people that like to flip pages, sometimes, that's helpful. And especially, like the one I showed with the snow plowable RPMs, the notes are right there to tell you the limitations of it, that kind of stuff. All right, did we have any other questions?
Do not anything else in the chat.
Well, hope everybody enjoyed it. Hope you learned something today, and look forward to next week. And next week, let me see, forward here.
Anthony, please stay on.
I can bring up Larry with the next week.
Yeah, so next week,
Requirements
look forward
for
to
HSIP.
requirements for HSIP.
All right, well, if there are no other questions in the chat room, I guess that concludes this week's webinar. I will end the recording now.